afternoon, friends. I am Tamilarasi, Assistant Professor of Marine Engineering Department in MIT University. Today, we are going to discuss about the power system protection and switchgear. What is power system protection and switchgear? Power system protection and switchgear are the essential aspects of electrical power engineering. So, switchgear refers to the control, protect and isolate the electrical circuits. It's mainly referred to the systems and the equipments. So it will be connected to the power system. So power system protection is nothing but the power system protection focuses on safeguarding the system from faults and ensuring the reliable power delivery. So why power system protection switchgear is needed? Power system protection switchgears are crucial for ensuring safe, reliable and efficient operation of electrical power systems. They work together to detect and isolate the faults, preventing the damage and minimizing the outages and maintaining the power flow. So power system protection and switchgear components are very, very important for the protection of the power system. So power system protection is integrated with power system switchgear components, equipments and systems to protect the power supply, the continuity of the power supply. And where and when the power system protection switchgear is implemented. Power system protection switchgears are implemented wherever there is a need to control, isolate and protect the electrical equipment and systems. This includes power generation stations, substations, industrial plants, commercial, residential buildings and renewable energy systems. The specific location and timing depend upon the requirements, that is the application of the protection. How power system protection switchgear is working? The protective relay is a critical device in power systems that detects faults and initiates stripping of the circuit breakers to isolate the faulty sections. It operates by monitoring electrical quantities like current, voltage and frequency and then triggering the response when these quantities deviate from the normal operating parameters. This can be done or achieved by the relays. So in the schematic arrangement of protective relay, the bus bar is connected, in the diagram shown, the bus bar is connected to the line through circuit breaker and current transformers. The current transformer primary winding is connected to the bus bar. Then the secondary is connected to the relay coil. This relay coil is connected with the trip contact. So this trip contact is included in a trip coil circuit which already consists of the battery. So this trip coil is next connected with the contact of the circuit breaker. This is a full schematic arrangement of the protective relay. Whenever the normal current flows through the bus bar, the normal current we are receiving in the line also. So it will be a limited, the current will be in the limited range. So there is no overcurrent. So the current transformer does not detect any overcurrent or fault current. So the relay coil does not operate, does not energize and trip contact does not operate. And the trip coil circuit does not operate and the circuit breaker will be in the closed normal condition only. When the fault occurs, the bus bar, the line connected with the bus bar gets overcurrent. So due to this overcurrent flows through the line, the current transformer gets a proportional overcurrent. This proportional overcurrent flows through the relay coil, that is a CT secondary. So the relay coil gets energized. Due to the energizing of the relay coil, the trip contacts get attracted. So due to the trip contact closing condition, the next sequence is the trip circuit get fully energized due to the battery connected with this circuit in series. So then the trip coil get energized. So the trip coil connected with the trip circuit is energized. Due to this trip coil attracts a circuit breaker. A circuit breaker contacts. So due to this, the bus bar connection will be open circuited. So the faulty part of the fault current or overcurrent flows through the line get disconnected. That is a section or the particular section is disconnected from the bus bar. So it will be isolated and it will be monitored and corrected for the further proceedings. So then it will not affect the overall busbar or other circuit. So the overall power system line is protected by using the combination of circuit breakers and relays. So both of them acts as a effective protection or switchgear element for the power system. So relay gives the information as a signal or alarm or any other indication like this. Circuit breaker disconnects a circuit. These are all the major important functions performed in the power system to protect the overall arrangements. So what are the main components? Here these components are current transformer. CTs are current transformer. The CT is a device that steps down the high currents of the electrical system to lower or safer level that the relay can measure, easily able to measure. Then voltage transformer. The potential transformer steps down the high voltages to the electrical system to lower level for the suitable relay operation. And what about the relay operating coil? This coil responds to the measured currents or voltages from the CTs and PTs, triggering the relay mechanism when fault is detected. And what is tripping circuit? Means this circuit connects a relay to the circuit breaker and allows a relay to initiate the tripping when fault current is detected. And next, contacts. The relay contacts act like switches, opening or closing to signal the circuit breaker to trip from the main circuit. And in the main working principle, what's the main concept of the relay operation is protective relay operates on the principles such as electromagnetic attraction and electromagnetic induction. Electromagnetic attraction relays are used in both AC as well as DC systems and operate by attracting the coil towards the electromagnetic poles. Electromagnetic induction relays, on the other hand, are used in AC systems. It utilizes induction motors to generate the torque. Up to this, the power system protection and switchgear, the introduction and the overall concepts is over. Thank you, friends.